Choudhury. So I am running this program in Jupyter Labs. This is my project for analysis of algorithms. The programming language is of course Python. I'm using the kernel to run all of this. As you can see here, this is pretty much a test case for just to show everything in this video. The end values I'm using 100, 600 to 1000. So if I hit shift and then I hit return, it pretty much does executes the entire cell for me. So pretty much as you can see, it does all the iterations per every n, does m iterations for every n value. The table, as you can see, does everything for brute force and divide and conquer. You have the empirical values for both of these two. You have the brute force empirical was predicted for both brute force and divide each. So that's what this test case does. And to show you how basically the code is set up, or kind of structured, excuse me, I'll pretty much go here and I'll show you how this all works. So pretty much I have the algorithm for brute force. It's over here. And then we have the algorithm for this basically follows the pseudocode found in the start in the class. And then you have divide and conquer. You have pretty much the base case over here. We start out with the base case. Then you have the actual division here of the points. And then you call this function that does all the quote unquote conquering. And that basically is calling this function over here, and you have the combining here. And so that's what this divide and conquer algorithm does. And then later on, we pretty much call this function down here where we have all the n values. Then we have then we run the experiments and generate we run the experiments, which I'll get into in a second. Then we run the tables and we plot them. So what we first do is we throw in the n value. We have the n values and we run these experiment. We have each of the n values. The first one would be like 1,000, then like I think 6,000, excuse me, then 11,000, etc. And you have m number of iterations per the m value, right? So you have 10 number of iterations per the n values, which we'll see later. And then we, of course, for every single n value, we run the experiments for both brute force and divide and conquering. We basically call this function that measures the time for both the brute force and the divide and conquer algorithm, and it pretty much appends each time towards this new array. So that's basically what this thing does. And then we pretty much put all the results into basically or kind of like a multi-dimensional array, and we basically pass that. So that's what this the actual most of the coding does. And then we have another function that quite literally just generates a table into different tabs, for the theoretical n values, empirical n values, and the running times for the actual empirical and predicted, and including finding the C1 and C2 values. And we basically plot all of that here, all here. And then so as you can see down here, we have the code in actual function for every single n value, 1,000, 6,000, etc. Excuse me. There is 10 iterations for every 1,000 value. The step up is 5,000. Excuse me. And we have the table being printed out here: 1,000, 6,000, 11,000, 16,000, etc. The theoretical RT values in this case would be like squared. The other one, it's n log n, so that's how the math works. And then you have the empirical values, which basically somewhat matches attempts to match that. And then we have the ratios and predicted RT values. So then we have the table for divide and conquer, which is again for division and conquer. We have the n values, theoretical RT values, which is n log n, empirical values, ratio of the two, and then of course the predicted running time. And as we can see down here, we have the empirical run times. Brute force is takes much more time to complete than divide and conquer, and so that's what we figured out here. And the brute force is also for empirical and the predicted around the same, and same for divide and conquer. So that's pretty much the extent of the kind of project. Thank you for watching, and please make sure to read the project code for any future details. Thank you.